In today's video, we are going to create a simulation for the summative assessment, which are found here. So we will answer the set B. So a half-wave rectifier with the series inductor and a DC source has an AC source of 120 volts VRMS and with 60 Hz frequency, and a DC source of 24 volts. Use PSpice to determine the value of inductance, which results in 50 watts absorbed by the DC source. Use default diode. So, in this experiment, we will create a half-wave rectifier circuit with those given parameters. So first, we will create a new project. So we will name it as Summative underscore exp for the summative 2. Then click OK, and then create a blank project. Then click OK. So now it's loading and blank, and we can see a blank canvas already. So for this experiment, we will place our required components. So place PSpice component, source, voltage source, and first we will place our sign, source or AC source. So we can use AC, but for accuracy purposes, we will use a sign. So source, voltage source, sign. There. So now we can see that there are requirements of amplitude and the frequency. So we will place another component, which is the diode. So here we will click diode, and then there, click escape to place another component, which is the inductor, which is placed over here. Then escape, and lastly our DC source, which is placed here. Of course, we should not forget the ground, so we will simply press G, then click OK, and now we will connect our component, and today we will connect our components. So just press W for wiring. So you just simply connect them in series. There. So now we will put our parameters for each component. For the V off, so we will press escape first. So for the V off, we will put 0 since it is not defined in the problem. Then V amplitude, so as we can see in the problem, as we mentioned earlier, it's 120 volts VRMS. And for the formula of the amplitude is VRMS times square root of 2. So we can put it inside the curly braces, then 120 times SQRT or square root, then open and close parenthesis, inside of it is 2. So we will click OK, and then frequency, which is 60, hertz, and then for the AC, we will simply put 0. And for the value of the inductor, uh, we will replace this since we cannot determine, since it is the missing factor inside the curly braces, which is L. It means that the value of the inductor is unknown. And for the DC source, we will just type 24 and click OK. So before we proceed to the simulation, we would add another uh, component or parameter. So we will click place and then part. So let's see. Let's try search here, and then let's take for the keyword param, which means parameters. So here we already see the param. So we will place it in our schematic, which means it is parameters since our inductor is unknown. So we will set parameters for our inductor in able to simulate the circuit. So right click, then edit properties. So we will add a new property. Click yes. So we will write L and its value we will simply put 0.1 there. Then click apply. Then yes. And then okay. Oops. So we will just close uh the part. So let's see if it is already saved. Yes, it is. And we will press apply. And then we will go back to our page. Let's see. Uh, display. So we say value, name and value. There, enable to show in our schematic. Let's say yes. Yeah, there. So now we can see the parameter L is equals to 0.1. So let's save it first. And now we will proceed to the simulation profile. So like before, eSpice, new simulation profile, and name it as summative underscore exp. Then click create. Now there is a new dialog box. So let's just say we will have a runtime of 1 period. 1 over 60 is 16.67 milliseconds, and our maximum time step is 10 microseconds. And additional to the simulation settings, we will check the parameter sweep. So we will go here to the linear, to the sweep type. So let's say the global parameter. So first set of the global parameter, and the parameter we are dealing with is L. So our start value should be equal to our set value parameter earlier, which is 0.1, and the end value 0.2. So it had an increment of 0.01, and then click OK. So for further to make sure it is really saved, so let's say apply, and then OK. And now we will run the simulation. Simulation, we will read this type of dialog box, which is the simulations for each value of uh, inductance from 0.1 to 0.2. So we will click OK. Now we will add the traces. So we will add the average power for each parameters from the V2. And now as we can see in one period, there are a lot of graphs, which means that in each line it represents uh, the waveform of the average power for each parameters of the inductance. So we will try to measure those, each of them at the end. So now as we can see, there is a lot of values here, and we will look on this portion. We will look which is closer to 50 watts. So as we can see, the closer to 50 watts is this one, which has a value of 51.157. Why we choose this one and not this 47.61? If we rounded it off, it only produces 48 watts as to the nearest whole number. But this one, which is 51, if we rounded it off, uh, it it will be closer to 50. So, as we can see, it has a circle which corresponds to its color. So we will click this one. So now we can determine what is the value of the inductance with uh with the 50-watt power absorption on the DC source. So our value of the inductance is 0.14. So if we're not sure if this is the accurate, so we will adjust the parameters for it for more precision by editing it in our simulation profile. So for now, it is 0.14. So we will click OK to exit that, and we will close this one. So we will edit the simulation profile to give us a more accurate result. So let's say it's 0.001. Let's try and run the simulation again. So now there's a lot. So click OK. And then add traces, the average power. So we will uncheck the voltage and currents just to make sure that we will down to the power only. And then click OK. As we can see, there's a lot of values. So we can toggle the cursor and we will measure it which among of them as the 50 watts. They are getting and yet more accurate. So this is more accurate, the peach one. So let's say this peach one. So as we can see, we cannot determine it, but it's 107.107. So we will try this again. But as we can see, if the parameters are getting tighter, it's very difficult to find a very precise number or very precise measure of inductance. But earlier we found out it's 0.14. So we will try it to substitute it with this one. So let's say it's 0.14 henries. And we will try to simulate it. Okay, wait. Let's cancel it first and edit our simulation profile. So we will uncheck this and click OK. And then go to Run PSpice and see if it is correct by plotting the average power of the DC source here. So let's try to measure it again using our cursor. So now, as we see on the end, it's 51.170, which is a bit closer than we received earlier. So this means that that is the real value of our inductor, which is 0.14 by when we place our simulation. So comparing it earlier, it's still 50 watts. So if we rounded it off by nearest whole number, so it will still closer to 50 since 0.13. So we will try to simulate using 0.13 to see the difference. Then we will run the PSpice and plot the average power across the DC source again. So now we will try to measure it. It's a lot higher, which is 55.082, which is not closer to 50 watts. So we will close it again and let's try the 0.15. And then run the simulation again. Then add the traces again. And let's try to measure its value. So it's 47.788. So as we can see, the most accurate measurement for in this simulation is 0.14 for the inductance, since its value is closer to 50 watts as it's stated in the problem. And this is how we measure or get the value of the inductance using PSpice. Hope you like this video and see you again next time.